Hi all, I'm Ryan Rice from the Washington State University Department of Chemistry, and in this video I'm going to give you an introduction to Microsoft Excel and hopefully help you out with your Intro to Excel exercise. I'm going to be working on a PC running the 2016 version of Excel. You might be running a newer version, but for what we're doing, most things should be pretty much the same. The first part of your exercise will give you a table of numbers and ask you to enter them into a blank Excel spreadsheet. For the example I'm going to work with, it's given me a table with the volumes of some rocks here in cubic inches and their corresponding masses in grains. All you have to do to get these numbers into the spreadsheet is just type them in with each number in its own cell. But before I do the numbers themselves, I'm going to give the columns they're going to go into some titles. The first column is for the rock's volume, so here in cell B2 I'm going to type volume. And then their units was cubic inches, which I'm going to abbreviate inches, just inches cubed. And then to that column's right, this is where I'm going to put the mass data. So I'll go mass, that was in grains, so grains. And if you look what happened here when I typed the word mass, it's kind of hiding the label just to its left for the volume. There's a quick and easy way to fix that. All we have to do is come up here between columns B and C, and when your cursor becomes this black vertical bar with the arrows coming off it, just double click there and it automatically resizes column B so we can see the label there. For the numbers, there is one thing to keep in mind when you type these, and that is to leave off the units. You'll want to indicate your units in the cell that heads your column, like I did right here when I added inches cubed after volume, but don't add them to the individual numbers. So when you go to type 0.3517 cubic inches in this cell, just type 0.3517 and not 0.3517 inches cubed. Later on I'll show you why, but for now let me get the rest of these numbers typed in. So if you look at what happened when I typed the number 251, Excel did something kind of nasty to me right here. It cut off the point 0. If you decide you want that displayed, in this case I do, all you have to do is come up here to the home part of the ribbon, number, and if you type this key right here, increase decimal, click that once and it'll move the decimal over and show the 0. The next couple questions will ask you to take the numbers in your columns and perform some calculations with them. They may or may not tell you how exactly to perform these calculations, and by that I mean whether or not you need to multiply or divide or whatever, but don't worry, there's a trick you can use to find out what exactly you need to do. And the trick goes like this. We're going to take what we're starting with, 0.3517 cubic inches in this case, and put it on one side of our equal sign, and then on the other side of the equal sign we're going to put the units we need, which in this case is milliliters. Now in order to get from this number of cubic inches to milliliters, one of two things has to happen. We're either going to multiply by 16.39 milliliters over 1 cubic inch, or we'll multiply by 1 cubic inch over 16.39 milliliters. And it's the units that tells us what we're going to do. Now since we need to cancel cubic inches to leave milliliters, this tells us that we multiply by something that has milliliters on top and cubic inches on the bottom. And therefore, it's going to be 16.39 milliliters over 1 cubic inch. Cubic inches cancels, and that leaves us with 5.764 milliliters. Now that we've used our units to figure out whether we multiply or divide, and as we just saw it's multiply for this first group of calculations, we'll move over here at this column where we'll actually do the calculations. Before we do that, we'll give the column a title. We're going to be converting volumes in inches cubed to volumes in milliliters, so we'll call it volume ml. And whenever you do a calculation in Excel, you start by pressing the equal sign. That just tells Excel, I want to do a calculation here. So for example, I might go equals 5 asterisk 5. Asterisk is Excel speak for multiply. Just press enter, and then that gives you the product of 5 and 5. In our case, we want to multiply this number, 0.3517 cubic inches, by 16.39 in this column in order to convert cubic inches into milliliters. So I'm going to go equal sign, click on that cell to highlight it, times 16.39, hit enter. There it's gone ahead and done the calculation for me. Of course, we also have to do the same operation for all the other numbers in this column, and this is where one of Excel's strengths comes into play. So instead of going to this cell and doing the same thing, going equals, highlight, times 16.39 and so on and so forth, all I'm going to do is click this first cell come over here to its corner, and you can see my mouse becomes a plus sign when I do that, and drag it all the way down. And there it's done each one of those multiplications for me, and without me having to type each thing out by hand. And then you just do something similar with all the other calculations you're asked to perform. In our case, going back to the original assignment, the next calculation line is to convert the masses in this right-hand column from grains into grams, and we're given the hint that there's 15.43 grains in 1 gram. Working this first one out by hand, we're starting with 251.0 grains, and we know there's 15.43 grains in 1 gram. So we need to multiply 251 by either 15.43 grains over 1 gram or by 1 gram over 15.43 grains. And once again, it's the units that's going to tell us which. So since we're canceling to leave grams, I'm going to put grams right there times something that has grams on top and grains on the bottom, which in this case is going to be 15.43 and 1 gram. Grains cancel, and we're left with 16.27 grams. So now that we know how to convert grains into grams, we can make Excel do most of the math for us. I'm going to do that over here in column F. In this case, we're converting masses from grains into grams, so give it a title that's appropriate, enter. Once again, it's kind of hidden this volume column there, so again, do your double click trick. That widens that column up, lets us see what the numbers are and see what the titles are. And then equals, highlight that column, and we're going to divide that number by 15.43. That gives us the number in grams, and once again, so we don't have to do it the hard way and do each one of those things by hand, click on that, drag it down, and once again, Excel's done all those for us, just like that. Moving on to the next question, it tells us that if we divide the mass of each rock in grams by its volume in milliliters, we'll get the density of those rocks in grams per mil, and to do that for all the data rows. So I'm going to go ahead and do that here in column H. We're calculating densities this time. So I'll just give the title density. And it tells us if we divide grams, that's this number, by milliliters. That's what we need to do. And once again, we'll use that trick, that drag it down trick, grab this, pull it down. There it's calculated the density of all the rocks for us. Before I go on to the next thing, I did want to show you real quick why you don't include units in your cells. So if, for example, in this cell I go 5G instead of just plain 5, and then if I come over here and try to multiply that by 2, you can see that instead of 10, I get this funky looking thing with an exclamation point. Basically, this is Excel speak for I don't know what to do. And if you get it or something like it, there's something wrong with your calculation, and you need to go back and figure out what exactly you're trying to do to what. The next question tells us to use Excel's average function to average the density numbers we just calculated. So first, when it says function, what exactly does that mean? Well, Excel has a number of these things built into it that tell it to do various calculations and operations and what have you with the figures in your cells, and these are called functions. For example, if I go to this box and I type equals average, I get this window that pops up with a handful of these functions, and then a box right here that tells me what each one does. The one we want in this case, it's in the first line, it's just called average, and to make it work, all I have to do is press the tab key, then come up here to the cells I want to average, then press enter, and just like that, we get the average right here in this cell. If you ever need to double check to make sure you're using the right formula, all you have to do is click on the cell you put it into, then come up here to this window right here, and this window will tell you what you've got in that cell. The next question tells us to use Excel's standard deviation function, or stdev.s, to calculate the standard deviation of the density figures we just averaged. We're going to do this sort of the same way we did the average, except we're going to do, instead of typing average, we'll start stdev. And this gives us a handful of different standard deviation related functions. The one we want is stdev.s, not .p. So select that one, tab, highlight the numbers, press enter, and there we have it. The next question tells you to highlight all the cells you have numbers and text in and to copy them into a Word document. I'm not going to demonstrate this one for you, it's just a simple copy and paste operation. So instead, I'm going to skip to the next question, and that tells you to construct a scatter plot of your volumes in milliliters and your masses in grams. So if we go back to Excel, if you come up to the Insert part of the ribbon, somewhere toward the middle you'll find options to make various charts. These unfortunately don't have labels on them, but if you click on them they'll show you what they do. This one makes column or bar charts. This one down here will give you pie charts. And the one we want right here gives you scatter plots. To make a scatter plot, all you have to do is highlight the numbers you're working with, which in our case is going to be our volume in milliliters and our mass in grams. Then come over here to Charts, click on Scatter, and for this exercise you want to use just a simple scatter plot with no lines. So click on that. You can see it gave us a chart here with our mass in grams on the y-axis and our volume in milliliters on the x. Once we have the plot, we can give it some titles. For the chart title, all you have to do is come up here, click somewhere on this box, and then you can replace the placeholder title they have with the one you want. In our case, we'll just call it Rock Mass versus Volume. Then you're going to want to give your axes some titles as well. There's a couple ways of doing this. The easy way is to come over here to this plus sign, and then just click on the box Axis Titles. And then same thing, click on the placeholder. This one is our mass. I'll just represent G with the grams with a lowercase g. This one's our volume, so volume in milliliter. Using the plus sign is one way. The other way is to come up here to Design and then Add Chart Element, and the Axis Titles options are also here. And this gives you the option of adding, if you wanted to, just the horizontal or just the vertical title. Before we go on to the next question, there's one more thing I wanted to point out here, and that is this other kind of chart you'll find in the charts area called a line chart. And the reason why I wanted to point these out is because superficially they resemble the scatter plots we want, but they're not scatter plots and they don't give you the same thing. For the sake of brevity, I'd rather not go into what exactly the differences between the two are. I just wanted to point it out so you don't select it by mistake. Next comes adding a linear trend line, and the way you do this is kind of like the way you added titles. So we'll click on the graph, go over here to the plus sign, and if you come down here trend line, you just click on the box just to the left of the word trend line. That'll put the line you want right on your graph. That's one way to do it. The other way is to come over here to Design, Add Chart Element, and you also find Trendline right there, as well as different options for different kinds of trendline. The one we want, of course, is linear. And I just now noticed that when I typed the formulas for the average and standard deviation in earlier, I forgot to give these numbers titles. So I might as well do that now. And you'll notice that when I type standard deviation in, the justification's off, so the word is hidden. I can fix that by coming up here to alignment, and I can go align right. Might as well do the same thing for average. And that fixes that. So anyway, once we have the trend line, if we click on it, then on the right side of the screen over here some options will appear for changing things like what kind of line it is. Or if we come over here to the paint bucket, it'll give us options for changing things like the color. Like for example, maybe would rather have a brick red line than a blue one. We can change the width, make it a little bit thicker or thinner. Yeah, 1.75, that looks pretty good. Dash type, if I want a solid line or this dot and dash sort of thing. I'll stick with a dotted line for now. And if we go back to this bar graph looking thing over here, come down past trendline options, you'll see an option here to display your equation on chart. And then it appears right there. Just move it a little bit so it's a little bit easier to read. You can see it's also kind of small, so if I come over here to the home part of the ribbon, come over here to font size, maybe I'll make it 12, it's a little bit bigger, a little bit easier to read. And finally, the last thing I wanted to cover is this question that asks you to use your plot to determine what volume a rock with a mass of 150 grams would have. So I'm going to go back to my chart, and I'm going to zoom in a little bit to make this easier on myself. Just come over and down. I'm also going to make a change to the x-axis. As you can see, its numbers are a bit spread out, maybe a little bit too much. I can fix this by first clicking on the axis, and then this brings up options over here on the right side of the screen. Click on the bar graph if it doesn't come up by itself already. Then come on down to Axis Options, Units, and I'm going to change the major units from 20 to, let's just go 10. And as you can see, that added a few more numbers to the x-axis, and that'll make the next thing I'm going to do that much easier. Getting back to the question, we were talking about a rock of 150 grams, so what you're going to want to do is go over to your y-axis, go on up till you get to 150 grams, then go straight to the right till you hit your line, then come on down and see where that falls on your x-axis. Now you'll notice we're between 50 and 60 mils here, and even though there's no numbers there that can tell us where exactly we come in, we can use another technique called interpolation to figure it out. To make interpolation work on this graph, what I'm going to do is take this segment right here between 50 and 60, and in my mind's eye I'm going to divide this section up and put in 9 markings of my own numbered 51 through 59. All I have to do now is figure out which one of these the imaginary vertical line that came down from my best fit line lies on. Going back to the full-sized graph, if I draw a vertical line here that intercepts the point where my best fit line comes up to 150 grams, and I imagine those markings in my mind's eye between 50 and 60 milliliters, I can see that this vertical line lies about on, let's call it 53 milliliters. And that's how you use interpolation to get volume from mass. So that's it. That's your introduction to Microsoft Excel. Once again, I'm Ryan from Washington State University, and I hope this was helpful.